Hey all, this is Guided Practice 8. So we are working on our guided practice problems from section 2.8 on the derivative as a function. So remember, write it down, have it somewhere where you can see it. In this case, we are using the fact that f prime of x is the limit as h goes to 0 of f of x plus h minus f of x all over h. Okay, so that's what we're working with. And let's go ahead and start in on this first one. So we're working with 3x squared minus x plus 1. So our good notation, f prime of x equals the limit as h goes to 0 of. Now, f of x plus h means that I'm going to take these two places where there are x's and replace them with an x plus h in parentheses. So 3 times x plus h squared minus, in parentheses, x plus h plus 1. Then I'm going to subtract in parentheses that function. So 3x squared minus x plus 1. And just a plain old h on the bottom. Now our objective is to go ahead and multiply all of this out. Okay. The trickiest one here is going to be that 3 times x plus h squared. So when I do 3 times x plus h squared, I'm going to do the x plus h squared first. If you need to write it out, that's fine. That's x squared plus 2xh plus h squared. If you need to write it out like this and FOIL, do that. Then multiply by your 3. So this is 3x squared plus 6xh plus 3h squared. That's what this first part's going to look like. So this is going to be equal to the limit as h goes to 0 of 3x squared plus 6xh plus 3h squared. Now I'm at the minus quantity x plus h, so that's minus x and minus h and plus a 1. For the green part, distribute that negative, minus 3x squared plus x minus 1 all over h. All right, now we know in order to cancel out that h, I have to have an h in every term on the top so that everything that does not have an h should cancel. So this negative 3x squared with the positive 3x squared. This positive x with this negative x. This negative 1 with this positive 1. And all the other terms have an h in them. So this is the limit as h goes to 0 of 6xh plus 3h squared minus h all over h. Then we're going to go ahead and factor out that h. So if we take the h out, we're left with 6x plus 3h minus 1 with an h on the denominator. Cancel those. Now we're left with the limit as h goes to 0 of 6x plus 3h minus 1. Now we can go ahead and evaluate the limit. That means I'm plugging in 0 for h. So that term will become 0, and we're left with 6x minus 1, and that is our derivative. Now on to number 2 with the square root. So same idea here. We'll get a look at the algebra on this one. So we're going to have f prime of x equals the limit as h goes to 0. And now I want f of x plus h. My only x is right here. So I'm going to put an x plus h in its place. So that will give me the square root of x plus h plus 4 minus the original function, which is the square root of x plus 4, and an h on the bottom. Now, if we plugged in our 0, this would all cancel out. We'd get 0 over 0, so we know we've got to do some algebra work here. We're going to multiply by the conjugate because it's square roots, so x plus h plus 4 plus square root of x plus 4. Square root of x plus h plus 4 plus square root of x plus 4. All right, got my notation set up. Now, on the bottom, I'm going to leave this factored as h times all of this stuff. In the numerator, I'm going to go ahead and expand this. So I'm taking this one times this one, When I do that, the square roots will cancel and I get x plus h plus 4. Then we know that the middle two will cancel each other out. So then I'm taking this one times this one. And that's going to give me minus quantity x plus 4. What happens now? Go ahead and distribute that negative. So negative, negative. And what will happen is that my x's will cancel and my 4's will cancel. And I'll be left with the limit as h goes to 0 of h over h times all of this business. And now my h's can cancel. And I'm left with the limit as h goes to 0 of 1 over square root x plus h plus 4 plus the square root of x plus 4. Now I can go ahead and plug in my 0 for h. So this guy becomes 0. Just the h though. And we're left with 1 over the square root of x plus 4 plus the square root of x plus 4. Now I like to think of square roots as just a label, right? These two things are identical, so I'm taking one of those square roots plus another one of those square roots. So that gives me 2 square roots that look like that. And that is my final answer. And then our last one is going to be one of the fractional ones. Okay, so let's set this up. F prime of x equals the limit as h goes to 0 of 3 over. Now, I'm replacing this x with an x plus h. So that's x plus h plus 1 minus the original one, 3 over x plus 1, all over h. Okay, now I have fractions and fractions. So the quickest way to get me out of this scenario is to multiply by both denominators. So I have x plus h plus 1 and x plus 1. So if I multiply by both of those, top and bottom, then I will clear my denominators. And that will give me the limit as h goes to 0 of. In the top, the first term there, the x plus h plus 1 cancels, and you get 3 times x plus 1. Minus, in the second term, the x plus 1's cancels, and you get 3 times x plus h plus 1. And on the bottom, as always, we're leaving this factored. We're not messing with that. Just leave it factored. Okay. Now we can go ahead and distribute all of these 3's. Don't forget to take the negative with you in the second part. So that's going to give you the limit as h goes to 0 of 3x plus 3 minus 3x minus 3h minus, whoops, not 1, but 3. And my denominator stays. Now everything upstairs that doesn't have an h in it cancels out. And then we're left with the limit as h goes to 0 of negative 3h over all of that business in the denominator. And now we can cancel that h because it's factored and cancelable now. And that becomes the limit as h goes to 0 of negative 3 over x plus h plus 1 and x plus 1. Then we can go ahead and plug in our 0. So this h will go away. And I'm left with negative 3, over x plus 1 times x plus 1. And I have 2 of them. That makes it squared. And that is my derivative. So for polynomials, we expand and multiply everything out. For square roots, we multiply by the conjugate. And for fractions, we're going to multiply by both denominators to clear everything out.